Welcome to Mind Overboard. In this video, I wanted to take a moment to discuss an interesting topic related to an upcoming book being released by physicist Sean Carroll. It's entitled Something Deeply Hidden: Quantum Worlds and the Emergence of Spacetime, set to be released on September 10th. When I originally read about the upcoming book, the promotional material was more sparse than its current form. I had planned on making some epic predictions as to the book's content. However, the current synopsis on Amazon provides some fairly clear and direct information, so the discussion may not be nearly as epic as planned. That said, there are still some interesting points and observations worth exploring. To set a baseline, here's the promotional blurb provided for the book. Most physicists haven't even recognized the uncomfortable truth. Physics has been in crisis since 1927. Quantum mechanics has always had obvious gaps, which have come to be simply ignored. Science popularizers keep telling us how weird it is, how impossible it is to understand. Academics discourage students from working on the dead end of quantum foundations. Putting his professional reputation on the line with this audacious yet entirely reasonable book, Carroll says that the crisis can now come to an end. We just have to accept that there's more than one of us in the universe. There are many Sean Carrolls, many of every one of us. Copies of you are generated thousands of times per second. The many worlds theory of quantum behavior says that every time there's a quantum event, a world splits off with everything in it the same, except in another world the quantum event didn't happen. There are a few reasons why it's exciting to see a book about this topic that has been written for a popular audience. As it says in the promotional material, this is a topic that is well known but seldom discussed. Well known by individuals who are familiar with the fine details and implications of modern physics. This means that the only details available to regular folks like us consist of what we can glean from educating ourselves about peripheral topics. This is likely partially due to the fact that the general topic of the multiverse falls into the realm of hypotheses that are highly speculative, likely difficult to observe or test, but possibly mathematically robust. So it's enticing, but when these factors come together, it usually squelches the appetite many professionals would have to pick out a singular model of preference and spend the time it takes to fully explore it. Most physicists are interested in pursuing avenues of research deemed productive by the possibility of tangible discoveries. Check out my video on the boundaries of human knowledge for additional explanation on why science or scientists tend to not fully commit to ideas with minimal experimental opportunities. It's partly the result of a natural desire to stick close to ideas and phenomena that can be discussed without what might be viewed as wild speculation. Another unfortunate reality of our current pioneering mentality relegates discovery for its own sake to flights of fancy or views it as a vestige of a whimsical bygone era. Ever since Tang hit and then dominated the marketplace, businesses and politicians alike, anyone potentially responsible for funding and therefore reaping the rewards of any potential new discoveries, have been laser focused on the concept of applicability. There's an ever-present desire to divine what new industry or technology we can squeeze from our pursuit of new frontiers. This ignores the fact that the practical applications usually represent spontaneous inspiration or the coalescence of disparate industries only after the new technology becomes available in commercial environments. In these cases, the new technology is often used to solve problems that are unforeseen by the original pioneers, and that lie outside the original intent for which the technology was created. Despite this, there's not a complete void when it comes to exploring ideas that rest at the boundaries of experimentation. David Deutsch, as an example, seems to be perfectly willing to apply what we understand at the frontiers of physics to everyday life. He applies this to the epistemological framework he builds in his book, The Beginning of Infinity. But before that, he had another slightly more technical book called The Fabric of Reality: The Science of Parallel Universes and Its Implications. Despite its title, it worked toward a specific thesis through a broad examination of several disciplines. It was not actually as focused on the multiverse itself as a subject, as I suspect this new book will be. It did contain an interesting argument that purported to show a clear physical demonstration of the existence of other dimensions by way of otherwise inexplicable interference in shadow patterns that we observe all around us every day. It's a novel, simple argument that demonstrates Deutsch's willingness to branch out into the tentative. It also represented a very small portion of the book. Another example that gets us a little closer to our topic is Brian Greene's book on the multiverse entitled The Hidden Reality. In it, Greene explains the mathematics and theoretical framework behind the concept of the multiverse, and then proceeds to explain the 9 possible multiverse models that have emerged as a result of this supporting foundation. One of them represents a multiverse based on the principle of quantum uncertainty. I'll refer back to an explanation by Sean Carroll to elaborate. We're all familiar with the notion of an atom, an unfathomably minuscule particle of matter comprised of several indivisible pieces: neutrons, protons, and electrons. Now, these pieces are actually divisible into quarks, but I'm talking about the commonly held conception. An atom is typically illustrated as a solar system-like symbol in which there's a center of mass consisting of a cluster of protons and neutrons, with some number of electrons orbiting it. In reality, we would see this image as a cloud. The cloud represents the electrons zipping around this minuscule space at an alarmingly fast rate, so fast that we can't properly discern their position at any given moment without without fundamentally changing their nature. The cloud is comprised of dark spots and light areas, and we talk about these spots being differentiated by probability. The relative darkness or lightness of an area represents the probability that an electron occupies that space in any given moment. The reality, as he describes, is that this is the incorrect way to visualize the electron. The electron, in actuality, is the cloud. It's not a discrete particle of matter zipping around. It's a probability cloud that's both present and absent at any of these individual locations. This is due to the fact that what we observe as individual particles when our observations pin them down to a particular place at a particular time are actually perturbations in a field that permeates space. Due to the Heisenberg uncertainty principle, the more we try to understand about one characteristic of a quantum particle, like its location, the less certain we can be about its other characteristics. However, it's not observation that causes this, it's an inherent function of quantum particles. I may be jumbling the connection a little bit along the way, so I encourage you to check out any of the books mentioned for more specifics. But circling back to Green, there's a model of the multiverse based on this principle. He talks about an elementary particle that, based on observational preference, may be shown to be on either one street or another. In one case, Main Street, in the other case, Elm Street. Since there is no set state for the wave function of the particle, it could be said to exist at both locations. But we can only ever observe it at one location. However, since this is a consequence of our observation changing the nature of the particle, this doesn't necessarily represent the true character of the particle. Without the influence of observation, the particle could be said to exist at either or both locations. Because of this, if we observe it on Elm Street, it could be said that there is also an alternate, concurrent reality in which it exists on Main Street. Unfortunately, he doesn't take the description much further than this, to my recollection, and it left me with some unanswered questions. Despite the fact that it's a quantum discussion, the analogy utilizes mid-level manifestations of quantum events like streets, street signs, and people who are observing. This raises the question of whether the analogy would apply to every particle simultaneously, and what would be implied if the answer to this is yes. It most likely should be applied in this way, universally to all particles in their multiple possible positions at the same time. He may have chosen not to take it beyond a fairly narrow threshold for the sake of simplicity, but it could also demonstrate a reluctance to dive too deep into a tentative topic, as we discussed earlier. This scenario appears to be what Sean Carroll is going to address directly and in great detail. It may help to think of this version of the multiverse in terms of time travel. I think we're all familiar with the concept of branching timelines, at least as of April 26, 2019, if not before. The idea is that if you go back in time and make a change, it doesn't change the future in unforeseen and unpredictable ways like in Terminator. It creates a divergent timeline branching into a new reality that unfolds based on this new input, away from the pathway of the original timeline which still exists as it had before. This could result in a multitude of branches based on the degree to which we make changes or abuse our time-traveling abilities. It's an interesting concept, but it's based on the idea that we live in a middle space of large objects comprised of a significant accretion of particulate matter over time. But we don't. We live in a quantum universe. The world we see and interact in doesn't reflect the way the universe actually is, which is why there's less and less room for intuition as we move closer and closer to the underlying reality of quantum physics and special relativity. To some degree, this requires us to become more comfortable with giving up our intuitions. Under this model, our universe would resemble the multi-branching decision-based universe of the time travel analogy, except we don't require time travel and the branching is not a result of the macroscopic. It's a naturally occurring consequence of the underlying randomness and unspecificity of our indiscernible parts. In other words, every particle that we could say exists in a multiplicity of space-times does actually exist in this way. The multiverse is something akin to a cloud of realities that branch off in infinite directions based on the multiple locations of the trillions of particles that comprise what we see. Each reality represents an almost imperceptible particle-by-particle shift from our own, but this shift is exacerbated by cumulative changes until we get to realities in which we don't exist and which don't resemble anything like the high-level manifestations of the quantum realm we're used to seeing. It wouldn't be right to think of them as discrete worlds occupying space in some other place that we could travel to through a wormhole or something. We're talking about worlds that exist all around us all the time. Or so I suppose. I think the bones of what we just discussed will be supported by the book, but I went out on a limb for some of the visualizations I attempted to evoke. It'll be very interesting and exciting to see all the theoretical explanations, supporting arguments, and evidence laid out. I assume a good portion of the book will be devoted to foundation laying and historical background, but rather than the topic being covered in a portion of a chapter or a full chapter, it's going to be the focus of a whole book, I hope. I look forward to the opportunity to learn more about this, and if you find any of this remotely interesting, you should check it out. Hopefully it will go far to establish a new baseline for how we understand the increasingly incomprehensible universe we occupy. And if you do read the book, I'd love to hear your thoughts on it in the comments below, or for you to point out any areas where I got it absolutely wrong. I'd also love for you to become a part of the ongoing conversation by becoming a subscriber to the channel. I hope you enjoyed the video, and thanks for watching.